In the first half of the 20th century, innovators combined electronics with chemistry to make new measuring instruments that extended our senses into the world of minuscule molecules into the chemical domain. In the hands of many researchers, scientists, and engineers, these electronic chemical instruments changed our world. At the dawn of this instrumentation revolution, entered a crucial scientist-entrepreneur, Arnold O. Beckman.
The instruments have completely changed science, completely changed chemistry for sure. Probably changed chemistry and biology more than anything else, any single thing. So Arnold's footprint on chemistry and biology is a huge footprint and will last forever.
He kept a childlike mind with respect to curiosity, that delightful openness to questions, and then the determination to find the answers to those questions. So I think that's what made him a true giant.
He really was a scientific icon of the 20th century.
A zillion people don't know Beckman. Beckman, you go down the street, nobody knows Beckman. It doesn't bother me because there's so many scientists who know and respect him.
Throughout his life, Arnold O. Beckman developed a multitude of innovative scientific instruments. He built a thriving business that made those instruments readily available for use in industry, Nobel Prize-winning research, and life-saving medicine. Later in life, he donated much of his fortune to advance science. His legacy is not only in the instruments he created, but in how these instruments continue to expand our view of the world. This is his story.
He got this job at Caltech. They kept him on. He was invaluable. They made him a faculty member. He taught a glass blowing course. He was an expert glass blower. What you need if you're going to fabricate instruments, it's always good to be able to blow glass in various fashions. And he knew about electronics. And so this guy came to him, an old classmate of his came to him and said, you know, I'm in the lemon juice business. I got to figure out how to measure the acidity of my lemon juice. And Dr. Beckman said, I think I can build you an instrument to figure out exactly how acidic your lemon juice is.
So I built an electronic amplifier for him to help him out of his troubles.
Arnold's solution to the problem was to use a vacuum tube amplifier to create a robust and widely useful pH meter.
This tiny voltage is amplified and finally is read out on a meter, the scale of which is calibrated directly in terms of pH. You see the needle swings over immediately to indicate the pH of 2.9. Let's measure an alkaline solution. Now immerse this in the soap solution. We see the needle swings over instantly to a reading of about 11.21. He came back in 2 or 3 months and wanted to know whether I wouldn't build him another one because someone else was always using the first one. I decided that was enough to start a business.
So one thing led to another, and he and Mrs. Beckman went across the country and they said, well, I can probably sell about 300 or 400 of these instruments. They started selling like hotcakes.
Arnold set up a little shop in Pasadena, California, where he started manufacturing and selling electronic pH meters. The instrumentation revolution had begun.
The hallmark of Beckman instruments was they were reliable. Around 1940-41, he put together this spectrophotometer, the Beckman DU, that just revolutionized chemistry and biology.
Well, Jack, I think it's only fair to warn you right from the start here now that you're talking to a fellow who certainly admires but just doesn't begin to comprehend the complexities of this great field with which you people here at Beckman are so familiar.
Well, Ken, I don't think it's really so complicated. I think we can give you a pretty clear picture here.
You refer to this as a spectrophotometer. Isn't there a simpler name for that?
Well, Ken, I think you might call it a fingerprint machine, if you like. You know how the FBI takes your fingerprint to tell exactly who you are? Mm-hmm. The chemist uses this machine to tell exactly what chemicals are present in a mixture and exactly how much of them.
Well, what different uses would this have?
For example, in the pharmaceutical industry, they tell how much vitamin A is present in pills.
Naturally, this is of tremendous value to all kinds of chemical manufacturers, to bakers, tire makers, textile mills, producers of vitamins, beverages, insecticides, paper, paints, cosmetics. The list is endless.
The Beckman DU spectrophotometer measured the absorption of ultraviolet light faster, cheaper, and more reliably than other instruments. It had profound consequences for Beckman's enterprise and for the chemical sciences. It brought powerful analytical techniques to growing numbers of scientists.
All these people are clamoring for it because, you know, it's like an iPhone or something. I mean, everybody wanted a DU. Every lab wanted a DU. Every biochemist in the world wanted a DU. And so he had to start making lots of DUs.
Over the course of 22 years, Beckman Instruments created over 21,000 units used in labs all over the world.
When I think of the discoveries that have been made in medicine, and most of them use Beckman instruments, the most important one has probably been the spectrophotometer. That opened up a whole new era of being able to analyze organic materials.
And that really changed biochemistry forever, and also part of organic chemistry. In fact, there was a famous biochemist who made a speech saying there are two eras of biochemistry, pre-Beckman and post-Beckman.
In June of 1940, President Franklin D. Roosevelt established the National Defense Research Committee to engage scientists in the war effort. This committee wanted to use science to solve some of the problems facing U.S. soldiers in battle. One such problem was keeping the right amount of oxygen inside an airplane or submarine. Soldiers operating in these low oxygen environments were sometimes affected by loss of consciousness and even death due to unchecked oxygen depletion. Caltech chemist Linus Pauling imagined a way to measure the amount of oxygen in an environment using oxygen's unusual magnetic properties. The National Defense Research Committee commissioned him to produce these new Pauling oxygen meters. Less than a month after receiving the assignment, Pauling and his colleague Reuben Wood constructed and tested a prototype. Though fragile and prone to decalibration, it worked.
We made one at Caltech to show that the principle would work. Then the Navy wanted 100 of them to go on board submarines. Came to me wondering if I'd take over the job of making these things.
Arnold Beckman was a logical candidate for such a job. In addition to his skills as an inventor, Arnold had a strong track record of producing reliable instrumentation on a mass scale. To simplify the production process, Arnold designed and constructed the world's smallest glass-blowing device. Arnold increased the manufacturing capacity of the oxygen meter to nearly 100 units monthly, at least 10 times what Pauling's team could have hoped to achieve. By 1955, Beckman Instruments integrated the oxygen analyzer with an infrared instrument and other technologies. It produced atmosphere analyzers that were installed in the U.S. Navy's nuclear submarine fleet. Arnold's oxygen analyzer took an interesting turn away from military uses after the war. Inexplicably, in the 1940s, a significant number of premature babies being treated with oxygen in incubators went blind. Doctors were baffled.
Some doctors at Johns Hopkins did a marvelous piece of medical detective work. They found that this was caused by excess oxygen. The incidence was highest in our best hospitals. These hospitals have the fancy incubators and like that. And they found when the oxygen got over 40%, retrolental fibroplasia set in, which is irreversible blindness. This appeared, say, in the Saturday Evening Post. Well, right away, we were deluged with orders out, so the sales just went up. And from then on, why, it's a good little business.
This early application of a Beckman instrument to improve human health was a sign of things to come.
Can you think of any one thing in particular that has given you the most satisfaction in all the things that you've done?
Yeah, the feeling that our instruments overall have resulted in benefit to humanity. The time I left Caltech, this was a difficult decision because anything that smacked of commercialism was frowned upon. And so I had to make the decisions whether I'd be prostituting my scientific training by going off into business rather than remaining in research. And not my own opinion, but many others, and say that I've done far more for science generally by making instruments available for thousands to use than just by what I could do in my own laboratory myself. So that's a source of satisfaction.